The universe is an ever-expanding mystery, full of fascinating facts and phenomena, with astronomers constantly on the lookout for new discovery. A recent discovery by the James Webb Telescope has deemed our galaxy center to be much more impressive than previously thought. By using the telescope's infrared capabilities, astronomers were able to detect a massive structure at the heart of the Milky Way. Normally, it is believed that the Milky Way's center is simply a single supermassive black hole called Sagittarius A, sitting within a large and dusty region of space called the Galactic Center. However, after observing this area with the latest advanced infrared telescope, NASA found 12 other newly discovered black holes all around Sagittarius A. These black holes range in different sizes, from the size of a small galaxy to that of our entire galaxy. They are all about the same distance from the center of our galaxy, which is within an elliptical region called the Sagittarius arm. What does this mean for our understanding of how big and complex the universe is? Could it be a sign for other galaxies? Is this another strange ripple in the fabric of reality, or is something more profound happening? Join us as we explore the huge structure discovered by the James Webb Space Telescope at the center of the Milky Way galaxy. Our home galaxy, the Milky Way, contains 100 billion stars, completely surrounded and followed by a large black hole at the very center of the spiral galaxy, 100,000 light-years in diameter. The name of our galaxy is derived from its spiral structure that resembles warped milk as we see it from Earth. It contains thousands and thousands of smaller galaxies orbiting around it like our solar system around the Sun. The Milky Way is part of a huge group of at least 100 billion galaxies, known as the Local Group. The Local Group was formed over 6 billion years ago by the combination of at least 4 other galaxies that would later be named Virgo Cluster, Ursa Major Cluster, Sculptor Group, and Hydra Centaurus Supercluster. The James Webb Telescope is the successor to the Hubble Space Telescope and is specifically designed to observe infrared light. The telescope has been designed for use by both NASA and ESA, European Space Agency, as well as other international space agencies, from small planetary missions up to large exoplanet missions. As one of NASA's newest infrared technologies, the James Webb Space Telescope uses advanced infrared technology and is regarded as the largest space telescope in existence. The James Webb Telescope is named after James E. Webb, an astrophysicist who became famous for his discovery of the galaxies visible from Earth, as well as his experimental work in radio telescopes. He also discovered numerous comets and was the first to spot water vapor on the Moon, which suggested that there was water present on the Moon's surface. Starting out as a teacher and then a NASA administrator, James Webb is well known for his contributions to NASA throughout his career. However, the James Webb Space Telescope can not only detect the light of stars and galaxies, but also the heat of their star-forming regions. The telescope was built to be able to image and study distant stars, as well as explore our solar system with an infrared camera that can look at a variety of planets, including the moons and asteroids. It will also be able to provide advanced data about the formation and evolution of stars, planets and exoplanets for human knowledge. It is estimated that the James Webb Telescope is able to see infrared light with a wavelength between 0.3 and 10 microns, which means it can penetrate into deep space where normal starlight cannot. The telescope is designed to be able to detect a wide range of infrared light from hot stars, warm dust clouds, and cooler objects like gas and water. It is also equipped with an advanced cooling system that can cool the telescope down to -233 degrees Celsius, which is much colder than any place on Earth or any planet in the solar system. This cooling system will ensure that highly sensitive infrared instruments can perform at optimal levels and allow it to look deep into space for thousands of years, rather than just 5 years like the Hubble telescope. The James Webb Space Telescope uses a large primary mirror that is 6.5 meters in diameter and is made from beryllium. Several instruments are placed on the telescope, including a near-infrared spectrograph, an infrared camera, an infrared spectrometer, and a mid-infrared interferometer. The telescope has been engineered to be extremely precise in order to provide the images needed for human knowledge and potential future NASA missions. Among its many tasks, the James Webb Telescope will be able to detect light that has traveled for 13 billion years, from 600 million years after the Big Bang, which was when the universe was first formed. When Webb launched in 2021, it was positioned 1.5 million kilometers away from Earth in order to prevent any interference from heat emitted by the Sun, and will orbit around a gravitation point of the Earth-Sun system called L2. With all these advances in technology, astronomers and NASA were able to discover that there were at least 12 new black holes at the center of the Milky Way. These black holes range from the size of a small planetary system to 12 times larger than our Sun. This discovery was made thanks to the infrared data provided by the James Webb Space Telescope. The infrared data provided a more accurate look at the center of the Milky Way, which was missing from telescopes in the past. To the best of our knowledge, these black holes are eating up neutron stars and binary stars, which are the leftovers from supernova explosions that occurred millions of years ago. The black holes are formed when a gas-rich neutron star collapses in on itself due to its own gravity and gravitational pull. During this process, the gas can get ejected out into space, creating a black hole which absorbs that gas for energy, surrounding it in an extremely hot and dense region of space. The researchers have been examining the infrared images given by the James Webb Space Telescope to find out exactly where each black hole is located and which stars they are consuming. This has been done to test if we can predict where they could be in the future, instead of only predicting them after they are discovered. Additionally, this will help us discover more black holes, such as those previously missed by telescopes in previous generations. One of the many benefits of the James Webb Space Telescope is its ability to detect infrared light. Infrared light is a very difficult wavelength for astronomers and other researchers to detect because it is blocked by water, oxygen, and methane in gases. These compounds absorb infrared light, which blocks it from reaching telescopes on Earth. With the use of the James Webb Space Telescope, infrared light can be detected for many reasons, such as finding out how stars are formed or learning more about exoplanets. Our ability to identify exoplanets and their characteristics is also improving thanks to this new infrared telescope. Using a lot of data, the James Webb Space Telescope will be able to find out if there are any planets that have stable orbits around binary stars, which is a type of binary star system where two or more stars are orbiting around each other. Binary systems usually result from the eruption of a supernova and can account for 2/3 of all stars in our universe. These binary stars are essential to our ability to understand how stars work and how they are formed. They also help us understand how planets form around these systems. Along with the James Webb Space Telescope, it is expected that there will be several other new telescopes launched into space, each focused on a different area of research. With these new telescopes, astronomers will be able to probe farther and observe objects in space, including exoplanets, at a much higher level than before. With the many new discoveries being made, the James Webb Space Telescope is providing a big impact in the scientific community and will help provide it with better insight into the workings of our universe. Due to the inability of humans to travel to different planets, it is very difficult to understand what the atmospheres surrounding these planets are like. This is why the James Webb Space Telescope will be able to conduct atmospheric studies of exoplanets and possibly even determine if they are habitable or not. Using the James Webb Space Telescope, astronomers will be able to analyze the atmospheres of exoplanets to search for traces of gases that could suggest the presence of life such as oxygen. Although the James Webb Space Telescope will provide lots of new opportunities for astronomers, it is not immune to criticism. Its weight and cost were two of the most notable criticisms that were brought up while the telescope was in development. However, the telescope has been able to overcome these criticisms thanks to the advancements in technology throughout the years, and the fact that some of its capabilities have proven to be worth it. We'd love to hear your thoughts in the comments below.